Bismillah ar-Rahman ar-Rahim. Welcome to the third part of the integration by parts. As we mentioned before, integration by part is just integration of product of two functions, u dv equal to uv minus integration of v du. In the last part, we mentioned different type of examples. Now we continue this topic by giving more examples. Evaluate. Number one, what is the integration of x squared cosine x dx? Integration of x squared cosine x dx. If I have cosine x multiplied by cosine x squared, we use integration by substitution. But since the power of the angle is less than the power of the x outside or in front of the cosine, so we cannot apply the integration by substitution. And that's why we need to use the other technique, which is integration by part. Don't forget our list for the u substitution or for the choosing u. It is L, I, A, T, and E. L for logarithm, I for the inverse trigonometric, A for algebraic, T for trigonometric, and E for the exponential. So in this case, I will say let u to be x squared, because I have algebraic and trigonometric, and A is coming first, then T, so this will be u. Now u equal to x squared, and dv will be cosine x dx. Differentiate the first one and integrate the second one. So derivative of du or u will be du equal to 2x dx. Integration of dv will give me v. Integration of cosine is sine x. So integration by part, it will be u multiplied by v minus integration of v du. So in this case, my integration, which is x squared multiplied by cosine x dx is equal to, it is x squared multiplied by sine x minus integration of 2x, which is v times du. We multiply now this one with this one. So it is 2x multiplied by sine x dx. But we notice that the second part, which is 2x sine x, also this can be integrated by part. By part. So I will have x squared multiplied by sine x minus integration of, I will choose for the second part. I will say let u to be 2x, and dv will be sine x. Now differentiate the first one, du will be 2 dx, and integrate the second one, v will be minus cosine x. So again, we are applying integration by part for the second time, for the second part of the right expression. So in this case, my function now, or my integration will be x squared multiplied by sine x minus open bracket. The second integration, I'm going to multiply u multiplied by v. Let me call it u2 and v2, for example, just to make it clear. I will have minus 2x multiplied by cosine x minus integration of these together. That will be minus 2 multiplied by cosine x dx, because I have 2 with minus cosine x. I will get minus 2 cosine x. Close the bracket. I will have then equal to x squared multiplied by sine x minus with minus is a plus, so it is a plus 2x cosine minus integration of cosine, because I have there, see, this is minus with minus is positive, with minus will be minus 2, and integration of cosine is sine x plus constant c, and that will be the integration. You can see that in this example we apply the integration by part 2 times. 2 times 2, find the integration of x squared multiplied by cosine x. And I'm going to give the detail of this technique in maybe in the coming examples. We have technique called the tabular method if we have a polynomial multiplied by another type of function. Let me take another example. What is the integration of tan inverse x dx? Integration of tan inverse x dx. We don't have explicit or clear function when we integrate aggregate tan inverse. So I cannot integrate this directly. I have to apply either integration by substitution, which is not possible in this problem, or integration by part. Now, if I want to integrate the function by part, I will see that this is inverse, a trigonometric function, and dx is a. So I have algebraic and inverse trigonometric function. And in our list, u or I is coming first or before the algebraic. So I will let u equal to tan inverse x. And dv will be 1 dx. So if we differentiate, I will get du equal to, derivative of tan inverse is equal to 1 over 1 plus x squared. And integration of dv is equal to v equal to 1x. So the integration, this will give me tan inverse x dx is equal to v times u, which is equal to x multiplied by tan inverse x minus integration of x, which is v times du, which will be x over 1 plus x squared dx. Now the second part, which is this integration, this can be done by u substitution. Or integration by, let me call it by substitution, not u. Let t equal to 1 plus x squared, the denominator. Then dt is equal to 2x dx, or dx can be written as dt over 2x. So this will give me integration of tan inverse dx can be written as x multiplied by tan inverse x minus. Now we are finding this integration, the second one. So open bracket to be integration of, or even also with other bracket, minus, I have x divided by t by the substitution 1 plus x squared equal to t. dx can be written as dt divided by 2x. Now I will simplify x with x, will be cancelled. So I will have x multiplied by tan inverse x minus, I will take 1/2 outside, integration of 1 over t dt. And the integration of 1 over t is equal to ln of t. So this is x multiplied by tan inverse x minus 1/2 ln absolute value of t plus constant c, because this is indefinite integral. Or it can be written as x multiplied by tan inverse x minus 1/2 ln, write it back, which is 1 plus x squared plus the constant c, and that's it. So this is the integration of the tan inverse. We apply the integration by part technique. We use, or we let u equal to tan inverse dv equal to 1 dx. Then we apply the integration by part to find the solution, which is x multiplied by tan inverse minus 1/2 ln of 1 plus x squared plus the constant c.